All right, guys, welcome to 6.5 Factoring Strategies. So everything you need to know about factoring is covered in 6.1 to 6.4. You want to watch those videos, re-watch those videos, and factor. 6.5 sort of just sums it up and gives you some friendly reminders. So this is just called Factoring Strategies, so nothing new, just accumulation of everything, so it's a good reference. So first thing, factor out the greatest common factor first. Don't forget this. Often students make their problems much more difficult by forgetting to factor out the greatest common factor. So let's look at 7x squared minus 28. So what's the GCF? Well, 7x squared and 28. 7 and 28 share a common factor of 7. There's no x's here, so we can't pull any x's out. And then what's left is going to be x squared minus 4. But then this actually leads us to the factor completely. Because if we look in parentheses, x squared minus 4 can be factored further. We know that this is 7. X squared is x squared, but 4 is 2 squared. So that's just the difference of squares. So we leave the 7 out front, and x squared minus 2 squared is just x minus 2 times x plus 2. So factor completely, right? Which is what we just did here. So factor out the greatest common factor, and then don't forget to make sure you look at what's in the parentheses and make sure you can't factor any further. So let's look at this guy. This one's a little tricky. We're going to first factor out the greatest common factor of 5. We get x to the 4th minus 1. Now, if we look carefully, this in fact is actually the difference of squares in the parentheses, because this is x to the 4th is really just x squared squared, and 1 is just 1 squared. X squared squared. So if we ignore the 5, x to the 4th minus 1 is x squared squared minus 1 squared. And we know that that factors. It's going to be x squared minus 1 and x squared plus 1. So what we're squaring minus that, what we're squaring, and then that plus that with the 5 out front. Right. But we're not done yet. Notice right here, this is the difference of squares too. This is x squared minus 1 squared. So x squared minus 1 can be factored even further. That's x minus 1, x plus 1. X squared plus 1 is the sum of squares. The sum of squares does not factor, and we bring the 5 down. So we took the 5 out, but x to the 4th minus 1 could be factored further. X to the 4th minus 1 factored into x squared minus 1 and x squared plus 1. But we have to factor completely. We have to look carefully inside the parentheses. We have the difference of squares here. That factored into x minus 1, x plus 1. So we put it all together. And 5x to the 4th minus 5 is 5 times x minus 1 times x plus 1 times x squared plus 1. All right, I know, a lot going on there, but pretty cool. Check your number of terms and think about what we do with those numbers of terms. If you have 2 terms, it's a binomial, and there's 3 special cases. Difference of squares, difference of cubes, and the sum of cubes. The difference of squares, if you have m squared minus n squared, so if you can break it up into something squared minus something else squared, it always factors, and the first factor is going to be m minus n, which is that expression without the powers. And then the second factor is m plus n. The same thing, but we just changed the subtraction to addition. So 100 minus 4b to the 4th. Well, don't forget to factor out the greatest common factor first. 4 times 25 minus b to the 4th. But that can be written as 4 times. Now, inside the parentheses, that's 5 squared minus b to the 4th is b squared squared. So now what's inside the parentheses is the difference of squares. So it's 5 minus b squared, because we just take the powers off. 5 plus b squared. And then just double check. That's not the difference of squares, because 5 is not a perfect square number, and that's a sum. So we're done. Difference of cubes. Let's do k cubed minus a cubed. Okay. So difference of cubes always factors. It's going to be k minus a. So we're going to write the expression without the powers. And then what goes next in the second set of parentheses is whatever's here times itself. So k times k, or k squared. What goes in the middle is that times that, so ka. What goes on the end is a times a squared. Now we have to be careful with the signs. If we started with subtraction, we keep the sign the same. Switches signs or goes to the opposite sign, and we always end with addition. So 125a cubed minus 8. I recognize 125 as a perfect cube number. I have a cubed. 8 is 2 cubed. It's a cube number. And b to the 9th can be written as something cubed. So let's do this. What can I put in the parentheses and cube it here? And what can I put in the parentheses here and cube it? Well, 125 is 5 cubed. And then we just have a. 8 is 2 cubed. Now we have b's. What power would we put on b such that if we cubed it, we got 9? Remember the power to power rule, we would multiply. So 2b cubed would be 8b to the 9th. So this is the difference of cubes. So this factors beautifully. My first factor is 5a minus 2b cubed. So just remove the cubes. 5a minus 2b cubed. Now we're not removing that cubed because that's on the inside. We're just moving the cubes outside the parentheses. Right? And then what's going to go here is 5a times 5a. And if you're comfortable just calling it 525a squared. What's going to go in the middle? Now don't worry about the signs. What's going to go in the middle is 5a times 2b cubed. And then what's going to go on the end is 2b cubed times 2b cubed. Negative, same sign as what we started with. We switch it to addition. We end with addition. And now let's just clean it up. 5a minus 2b cubed. 5a times 5a is 25a squared. 5a times 2b cubed, 10ab cubed. 2b cubed times 2b cubed, be careful, that's 4b to the 6th. b cubed plus b cubed we add. Power to power we multiply. Distinct bases, or two bases, same bases with powers, we add. So that would be my final answer. Difference of cubes. So when we look at, we have 3 special cases with our trinomials. The last one is the sum of cubes. So L cubed plus M cubed is, well, the first factor, take off the L and the M. Take off the power off of the L and the M. L plus M. And what's going to go here is L times L. What's going to go in the middle is L times M. What's going to go on the end is M squared. We start with addition, same sign, opposite sign, positive. 64 is a perfect cube number. Let's look at this example. M is cubed and 1. So we can rewrite this as something cubed minus something, nope, plus. Ooh, that's supposed to be a plus, another typo. I'll fix it before you get it. So let's look at 64 m cubed plus 1. All right, so just changing my problem. So 64 m cubed plus 1. Well, 4 cubed is 64 and m cubed is m cubed. Now don't forget, 1 is both a square number and a cube number. So that's going to be 1 cubed. So that definitely factors. Sum of cubes always factors. So it's going to be, we take the power off of the outside the parentheses. It's going to be 4m plus 1. And what goes first here is just 4m times 4m. What goes in the middle is the 4m times the 1. And what goes on the end is 1 times 1. Addition, we started with addition. We keep the same sign. We switch to subtraction, always end with addition. 4m plus 1 times 16m squared minus just 4m. 4m times 1 is just 4m, and 1 times 1 is 1. You can always check all of these. Then we talked about trinomials, 3-term expressions. So we can guess and check or do the AC method. Right. So let's factor 3t squared minus 11t minus 4. You can guess and check. I'm going to do the AC method. Now, I can't just do two numbers whose sum is negative 11 and product is negative 4 because of the 3 out front. I'm going to do two numbers whose sum is negative 11, but whose product is A times C, which is negative 12. Again, this is A. B is negative 11. C is negative 4. So this is B, and that's A times C. That's where the name AC method comes from. So I know that this is going to be negative 12 and 1. So I'm going to take this 3t squared minus 11t minus 4. And I'm going to replace the middle term with negative 12 t's and 1t. So 3t squared minus 12t plus 1t minus 4. If you do it correctly, this will always group 3t. I'm going to get t minus 4. Oh, we haven't come across like one of these in the note chat. Well, 1t and 4 has no common factor other than 1, but my suggestion is we need t minus 4, which we have there. Pull out the factor of 1 because we're going to need that as a placeholder, because now we're going to take out the t minus 4. And before you conclude there's nothing there, don't forget there's a factor of 1. So we're going to have t minus 4, and when we group, the second set of parentheses always has to have two things in it. So it's going to have the 3t plus 1. Okay. So we used grouping in the AC method, so therefore 3t squared, we actually talked about our last one. There we go. And you can check the product of the first is 3t squared. Product of the last is minus 4. The inners give me negative 12 t's plus 1t from the outers gives me my negative 11 t's. And then lastly, grouping. Okay, so as is, this may, let's see if I try grouping right away. So if you see a 4-term expression, try grouping. Just want to make sure I don't have a typo before I... So let's look at this guy. So if I do 6n cubed plus 4, I can pull out a 2 and get 3n cubed plus 2. The only thing I can pull out here is n, and we get 3n plus 8. All right, so that's not going to work very well. So we may need to rearrange. Let me do... I have 6n cubed, and 3n squared has a lot in common with that. Let me put the 3n squared next to the 6n cubed. And then I'm going to do, we have 4 plus 8n left. All right, now let's try grouping these guys. Let's do these and see if that works. I pull out the 3n squared. You can get 2n plus 1, right? Here I can pull out a 4. I get 1 plus 2n, pulled out a positive 4. Now notice 2n plus 1 is equivalent to 1 plus 2n. You can switch the order in which you add. I like 2n plus 1, so I'm going to change this to 4 times 2n plus 1. You are allowed to switch the order in which you add because addition is commutes. So now we can pull out the 2n plus 1. And if we pull that out, what's left is the 3n squared and the plus 4, and that becomes our second factor. All right, kids, factor, 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 factor. Factor your hearts away. Catch up with you soon.